Hi, today's lesson is about solving a quadratic equation by the completing the square method. So, completing the square method and the quadratic formula allow you to solve any type of quadratic equation, but factoring and the square root method can only be used in specific cases. So, with the completing the square method, the equation does not have to be in standard form. Actually, it cannot be. To use this method, the variable terms and the constant must be on opposite sides of the equal sign, and the coefficient or the leading coefficient must be 1. So, meaning the x squared term must just be x squared, not any other number in front of it. So before we start doing that, we must remember what a perfect square trinomial is. So examples of perfect square trinomials are here below. And so the concept of a perfect square trinomial will appear within the completing the square methods, which is why we're just reviewing this first. So a perfect square trinomial is a three terms where when you factor it, it's the same binomial twice. So here in example number 1, x squared plus 8x plus 16. If you were to factor that, it's x plus 4 times x plus 4, which is x plus 4 squared. If we go over to number 2 in green, x squared minus 14x plus 49. Well, that's x minus 7 times x minus 7, giving us x minus 7 squared. Now let's look at number 3. That says z squared plus 10x plus 25. Well, that's z plus 5 and z plus 5, which is z plus 5 squared. So after seeing these three, I'm usually hoping that students see the pattern. So let's just discuss the pattern briefly with this last one that we did. Notice that my middle term is 10, and my factors are z plus 5 and z plus 5. 5 is half of 10, but 5 is also the square root of 25. That is the case with all of these. So let's look at this one. Half of negative 14 is negative 7, and then the square root of 49, remember that's plus or minus 7, and so that relationship exists here as well. All right, so here I am at number 4. W squared minus 16x plus 64. So half of that is 8. Square root of 64 is also 8. Make sure that the sign in the middle corresponds with the sign of the second term. And that will be true anytime you're factoring a perfect square trinomial. All right, so let's see where this appears in the completing the square method. So we have your examples of solving by the completing the square method. All right, so we want to solve x squared plus 10x plus 16 equal to 0. So that's an equation in standard form. But as I mentioned before, you do not want your equation in standard form. So first step is to subtract 16 from both sides. So that's where we're at here. I have x squared plus 10x equals negative 16. Notice that I left some space next to the 10x because in the next step, we are actually going to complete the square. Now, completing the square means that you take half of the coefficient of x, which for us is 10, and that gives you 5, so the work is here. And then you take that 5 and you square it, and that gives you 25. That number 25 gets added to both sides of the equation, which you see in line 3. The 25 is in red, and it gets added to both sides of the equation. Remember, with equations, as long as you do the same operation to both sides, that is okay to do. So on the left side, x squared plus 10x plus 25, well, that's a perfect square trinomial. Actually, we just talked about it right up here. That factors into x plus 5 squared. And the right side, negative 16 plus 25, well, that equals 9. So I'm left with x plus 5 squared equals 9. Now, I'm actually going to use the square root method within the completing the square method. So I take the square root of both sides of the equation here. So I have x plus 5 squared, the square root of x plus 5 squared is equal to the square root of 9. And on the next line, I get x plus 5 equals plus or minus 3. Subtract 5 from both sides, you get that x is equal to plus or minus 3, but negative 5 and plus or minus 3 can be combined. So on the next line, negative 5 plus 3 is negative 2, which is right here, and negative 5 minus 3 is negative 8, which is right here. Now, I chose this example because it's an easy one to illustrate the completing the square method, but this particular example could have easily been solved by factoring. So that's always an option as well. If it's factorable, that's usually much faster than completing the square. So I'll just show you the same equation. So this is what we started with, x squared plus 10x plus 16 equals 0. That is in standard form. So when we go to factor it, we're looking for two numbers that multiply together to give us 16, but when you add them, you get 10. So x plus 2 and x plus 8 works. And we get the same two solutions we did with the previous method. X is equal to negative 2 and x is equal to negative 8. All right, so let's move on. In this next example, this number 2, you would not have been able to solve this by factoring. So we're going to use the completing the square method. So in the first thing I did was move the 1 over to the other side, which is why the 1 becomes a negative 1. Then we take half of the coefficient of the middle term. The middle term is negative 5. And so the work is here. Take half of it, we get negative 5 halves, and then we square that number. That gives us 25 over 4. The 25 over 4 gets added to both sides of the equation, and again, it's in red so that you can see it easily. So in this third line, you factor. This is again a perfect square trinomial, although not something you're used to seeing because of the fraction, but it works the same way. It's x minus 5 halves squared equals, and now the negative 1 is written as negative 4 over 4 plus 25 over 4. How do you know what to put here? The work is really done. Once you take half of the middle term, you get what that factor should be. The negative 5 halves should be right here in that work you did on the side. So it'll be x minus 5 halves squared equals 21 over 4. So now we're ready to take the square root of both sides, which we have right here, taking the square root of both sides. Then when you take the square root of both sides, the left side becomes x minus 5 halves, and the right side becomes plus or minus root 21 over 2, because the square root of 4 is 2, so that changed there. Then add 5 halves to both sides of the equation, and you have 5 halves plus or minus root 21 over 2, which so it can be written like this, or you could write it as a single fraction because they have the same denominator. That's the same as 5 plus or minus root 21 over 2. Okay, so let's move on to another example. We have 2x squared minus 3x minus 4 equals 0. Same idea, we need to move the 4 over to the right side, so we add it. We have 2x squared minus 3x equals 4. But at the beginning of this lesson, I told you that the leading coefficient, or the coefficient of x squared, must be 1. And this one has a coefficient of 2. So that's a problem. We need to get rid of that. So we do that by dividing both sides of the equation by 2. And when I do that, my left side becomes x squared minus 3 halves x, and the right side just becomes 2. That's this line here, everything you see in black. But now I have to complete the square. To complete the square, I take half of negative 3 halves. So that work is right in here. And half of negative 3 halves is negative 3/4. Then I square it. And so negative 3/4 squared is 9 sixteenths. 9 sixteenths gets added to both sides of the equation. So on the next line, we're ready to factor the left side. This is, again, we're factoring a perfect square trinomial. So that's just x minus 3/4. Again, that minus 3/4 comes from here. And that equals 32 over 16 plus 9/16. Now, where did the 32 over 16 come from? Remember, in the previous line, it was 2, but I need to combine it with 9/16. So 2 is the same as 32 over 16. So now I have a common denominator. So now I'm right here. I have the square root of x minus 3/4 squared equals the square root of 41 over 16. When I take the square root of both sides, I get x minus 3/4 equals plus or minus root 41 over 4. And again, the 4 came from taking the square root of 16. And then I need to isolate x. So I add 3/4 to both sides. So x is 3/4 plus or minus root 41 over 4, which is a perfectly fine answer. Or you can write it as a single fraction as 3 plus or minus root 41 over 4. So now you should try doing the homework. Hope this helped.